Okie dokie, so let's start. Hello, my name is Stanislav. Yeah, as I said, you can open this link. It's an open source Streamlit app, so there are no private data or anything. So just you can you will be able to follow it here, or you can also do it yourself in your own laptop. Like about me a little bit, as I said, I'm from DTITCZ hub and working for Frag Magenta team or whole hub. I'm a data scientist, so mostly focused on the questions related to statistics, machine learning, and so on. And today, wanted to show you one of the approaches actually which arised in our hub. So that's basically for those of you who do not know how the Frag Magenta chatbot looks like. It's the one you would see actually on the link. And the difference from other chatbots, at least those which I know about, is that this one faces the real customers. It's not internal, it's facing DT customers. And of course, the question which normally we would ask ourselves, how does it affect them? Do they like it? Don't they like it? Maybe it's for nothing, all the effort and so on. And here, maybe the first question, like, also feel free to interrupt me at any time and so on. Who of you know what is A/B test? If you can raise the hand. Okay, so then I will just shortly, because most maybe haven't heard about it. It's nothing fancy, but it's good to talk about it a bit. So in general, is it big enough? Do you see? Okay, if not, then I'll increase. Like, the idea is actually very simple. We have two versions of some software, let's say front end, and then we deploy both of them, but we show to 50% of the customers only one, and to the other 50% of the customers the other. And in the end of the test, we look at the metrics and just compare which one was better. Like, it's, I would say, very much a common sense approach. Why to do it? It's not about some academic curiosity, it's more about how to improve the product, because we don't know what our customers like, so we can only approach them in the way that we propose something and see how they react. And that's actually what A/B testing is doing. So in a nutshell, that's actually a process. It's not like we test it one time and forget. It's more like we set the goal, what we want to achieve, define the metric, deploy versions, run the test, get results, analyze them, leave one of the options, and repeat the whole process again. Also a little bit about what type of testing it could be. If we have only two options, well, it's A/B testing, and if it's more, it's multivariate, and this will actually play a significant role later, because, and that's one of the, well, first maybe the drawback of the A/B tests. If you again can maybe raise the hand who have heard about spurious correlations. Okay, then I will explain. It's actually a very interesting thing. If we look for some correlations long enough, we will finally find something. And for example, if you go to the statistics website and you calculate those correlations, you'll find the one for US spending on science versus suicide by hanging, or distance to the Neptune versus the popularity of the Andrea's name. So this already implies that this A/B testing is actually a little bit tricky, that you can, like, as the saying goes, there is lie, there is terrible lie, and there is statistics. So not to get in this trap, we should be really careful about what we're doing. Next, speaking about the metrics, actually, how do we measure if customer likes us or not? There are plenty of them. I took some examples from our hub, which we're using. It can be simply rating. It can be in NPS, it can be acceptable answer rate, and they have different scales. And actually later we will have a look why it matters, why the metric matters. Here, like, I'll just scratch a little bit of statistics. Like, the first idea, as I said, we separate the traffic into two groups and look at the end which performed better. So is it enough or not? Well, obviously, I'm sorry for those of you who study statistics because it's very superficial, but I just wanted to show the logic that, let's say in two cases when we have exactly the same means and even the difference between means is the same, like in the case one, we're kind of more sure that there is a true difference compared to the case two. And why is that? Well, obviously because of the variance. Because variance in the case two is much bigger, and that's what we normally observe. Then, like in typical way how to evaluate the results would be a t-test. So this takes into account the variance, but it has a little bit of like actually not a little bit, but quite some limitations because we have very strong assumptions on the data which we get. They should be normal, and even the variance between the samples should be equal. So this is not often applicable. How to deal with this? In practice, typical way. Yeah, actually, also I'll stop by a little bit about the minimum detectable effect, because when the business comes to us and they say, okay, we develop two versions and provide us some evidence that one is better than another, then the question which we have to ask them in turn, how much better it should be. Because it can be better for 1%, it can be better for 10%, and depending on this, we'll have to have different sample sizes. And that's actually the question which is very typical, and sometimes it's hard to explain to business that I cannot answer both questions at the same time. What's the sample size? Yeah, that's actually what they also ask, how much data we need. Well, I can answer how much data we need if you will tell me how much effect is big for you, or vice versa, but not both at the same time. And that's the concept which is also important to understand. So what if assumptions are not met? Because here, so far, we look at the very nice Gaussian distributions. What if they're not like this, which is, for example, the NPS score? As you remember, I mentioned that that's basically the metric which reflects how much customer likes us, and it rarely happens that they like us on average. That usually happens that they either dislike us a lot or like us a lot, and it looks like U-shaped distribution, so assumptions for t-test are not met, so we cannot use this kind of test. What are the ways out? Well, still we can stick to the A/B testing, and normally in such cases Bootstrap is used. It has some very nice properties. One is that actually especially for business purposes, we don't care so much about the metric, but we can switch to the mean value of the metric, let's say mean acceptance ratio, or let's say mean NPS. And by using the Bootstrap, like I think those of you who have used it, you would know. I would maybe not stop now into details because we'll run out of time, but the idea is that when you are drawing samples from any distribution, the distribution of mean of those samples will be always normal. And this actually shown here in the picture, and that's this effect is widely used for bootstrapping, for A/B testing. Or we use just a non-parametric test, which is U-test from Manny Whitney. This is all okay so far, and actually this works fine in practice, and that's how A/B tests are done in production. But still, there are problems. If you remember, when we were talking about the minimum detectable effect, well, the picture is a little small, but no worries, we will look in the simulation exact same picture. When we speak about this minimum detectable effect, let's see if we search for effect of 2%, which is here, we would need a sample given the data. We will need a sample of 5,000 observations, which let's say 5,000 people who would see this A version of the chatbot. And for one variable, actually, that's a real, this calculated in real data. And for another variable, it can be 10,000 observations. And now let's ask ourselves a question: do we really want to show to 5,000 people the version of the chatbot which is underperforming? Well, that's for business, maybe it can be a problem. Yeah, what if like these 5,000 people, like how it will affect their, let's say, the image of the company afterwards? Because those who like, they probably will remain silent. Those who didn't, you will see it everywhere. So that's already a disadvantage which you cannot get rid of in A/B test because you have to keep it still. Second thing, that it is delayed because, for example, in Frag Magenta, we deploy new versions, let's say, every week. So we simply have no time to properly test it. Sorry. That's, again, a no-go for A/B testing. Other thing is it's inflexible. So what also typically happens, maybe it doesn't happen for Frag Magenta, but in other teams it happens that, okay, we split our groups, we run the test, and meanwhile, somewhere in marketing department, they decided to make the campaign and didn't tell us about it. So then we see that one group performs a lot better, and we cannot explain it just with our data. So that's also something which makes this A/B test very fragile. And finally, the external factors, like it's something which might happen during the A/B test, and it will affect even both groups, but in such a way that the initial relation between them is no longer feasible. And also, in this case, we have to start all over again with A/B testing. So those things, and actually some others, they cause problems. And what I saw in business practice, it results in that no A/B test is conducted. It's just like we have some version of chatbot, and based on some gut feeling, we will deploy it and hope for the best that it performs like as it should. And then after actually a couple of months, usually from management comes the question, we have our metrics going down, why is that? And well, and there is no easy way how to answer this question, so we have to infer something. And here comes to this stage in reinforcement learning. Maybe here I would also ask who of you, if you could raise the hand, ever heard or maybe even dealt with this? Okay, so then things would go faster, I guess. I will not repeat, like the idea of reinforcement learning is very simple, actually. You have the agent, you have the environment, and this agent does some action, and based on this action, he gets the reward, and based on the reward, he decides what would be next best action. So, like, it's very simple, but also when you dig inside, it's very complicated. So, today I'll touch only the simplest version of reinforcement learning algorithm, which is multi-armed bandits. I guess if you know about RL, then you know about the bandits. So I just shortly say like a few words about what is that. The idea originated actually from gambling, and among gamblers there is a certain belief that some machines, they are more kind of profitable than others. They think, okay, this machine in the casino somewhere in Las Vegas, when you pull it, it gives you more often the reward. And I don't know if it's true or not, I'm not a gambler, but what's the assumption behind? Actually, it's exactly the same assumption as for A/B test, that behind each machine we have certain distribution. And what the algorithm tries to do by pulling these machines in different times, he tries to figure out what is the distribution behind. So very simple. And what is the advantage against A/B testing? Well, first, in classical A/B test, I'll make it maybe bigger. We separate groups, run the test for a fixed amount of time or duration, and then look at those which perform the best. But during this time, like 3 groups, 1, 2, 3, they were exposed to underperforming chatbot. In the case of multi-armed bandit, we answer pretty much same question, but we're actually adjusting at every stage the allocation of the traffic. So the best performing chatbot gets the most traffic, but others, they still have their chance. If something will improve on their side, they will get back. For example, it happens here. And it's actually something what happens in Fragmagenda a lot. We have right now 3 competing chatbots, and teams are working hard to make their solution to win. That means that every week we have some new tweak or deployment, and it's even unfair to cut the rest based on some short-term tests. So this approach might be better in this regard. And in terms of customer satisfaction, so in the case of A/B test, well, during the, let's say before the test, we had it in some level, and during the test, or after the test, we deployed the newer version. And then again, when we start the test, customer satisfaction can go down just because we're exposing it again to underperforming option. In the case of Bandit, that's like keeping it on the more or less stable level. So here, maybe a little bit about what would be also important about the learning methods. So actually, how do we allocate it here? There are different ways. The simplest, maybe also again, I'll ask who has heard about these strategies, how to select the action for multi-armed bandit, these epsilon greedy and okay, well, it's much less hands. Then I will go a little bit more into details. Actually, the whole idea behind it is that how do we choose which arm to pull? And again, it's very simplistic. Actually, it's based on some distribution, which we learned so far till a certain step. And the most simple way is that actually we're doing it based on uniform. That means that we set some probability, let's say 5%, And with this probability, we pull the random arm, or in our case, we get the traffic to the random chatbot. And in the rest of the cases, which is 95%, we give it to the best performing so far. Like fairly simple. We're using, like actually what happens here, we're using the chatbot which is the best, but others also has their chance from time to time. Some more complicated ways, like I will just touch them on the surface because maybe it's not so much important, but in the end it's again about some distribution, but we adjust it in a way that, okay, in the beginning probably we don't know so much about the different chatbots, so let's give it more equal chances, but later, and it's actually the factor of time, t here, this one, we more inclined to those which perform better so far. And softmax is pretty much the same. Actually, it's the same softmax function we use in neural networks. So you don't just use one probability, use distribution and draw from this distribution. I hope it's clear so far. And if something is unclear, feel free to ask, but I think the essential points we touched. So now let's, how much time I have? 25 minutes. Okay, I'll speed it up. So if you have access, you can try it yourself. I didn't upload the data though, so I'll show first for A/B test how the preparation looks like. So the data we typically get in is, let's say, some session ID, question. It's maybe too small. Okay, then. Sorry, I cannot increase it, so you have to trust me that it's question, answer, and later I just renamed the metrics because of the PSA and so on, but it's actually some quality metric if the answer was satisfactory or not. And how we collect them, it's also a question. It can be automatic scoring, or it can be scored by annotators, which happens now. So for these metrics, then let's select, for example, 2 of those variables. And the graph we're looking at now, it's actually the same was in theoretical part. So we can automatically calculate how much data we would need for different effect sizes. So if we search for this 2% effect, we would need these 5,000 observations for variable 1 and almost 10,000 for variable 2. And usually, like, luckily for business setting, maybe this 10% is actually the difference they're looking for, and there we can, I will increase it here. So here we would be roughly on 300 observations. So that's something what is very doable, but again, depends what the business wants to see. If they want to see 1% difference, well, they will have to collect data till Christmas. And here, yeah, also, like, why I made it uploaded on the Streamlit, you can try it on your own data, and here you already can see from the distributions even that why actually for variable the blue one, we need so much more data. Well, because it has wider variation. It has 0.02 variation versus 0.01 variation. So this a little bit answers the question how much data we would need, and we can, actually this was used for A/B test definition recently in FragMagenta. And now for the interesting part, actually, to compare those two algorithms. So I couldn't use, or actually I didn't even try to use production data for such a presentation, so I simply generated them. And but you see that actually distributions are quite the same. So here in the minimum detectable effect part, like we have certain distribution which is, let's say, roughly Gaussian. So we can generate same distributions and give them parameters, but it has a benefit that we can really see, like we define what's the difference, and then we try it with the algorithm to find this difference. So let's say we have a blue bot, which mean, let's say, score or some acceptance ratio value will be 0.7. And then it has also deviation of 0.05. So that's this, I'll make it a bit bigger, this blue distribution. So it's not so stable, but it has high performance. So that actually was something what we have in FragMagenta. Then we would have, let's say, this light blue bot, which would have mean value of this metric acceptance ratio, for example, 0.65. So it's slightly worse than the dark blue one, but also it's more stable. It has smaller standard deviation. We have, like we can see it here, so less variation, higher mean. And for the fourth one, let's say I called it red. Let's say it's some uniform. That means like it's really falling from one side to another, and sometimes perform this way, sometimes other, just to compare them. But on average, we would say that the mean would be somewhere here in the middle, so he should be in the middle of the blue and light blue. Now let's try the algorithm. So the first one would be epsilon greedy. It's the simplest one, so it has only one parameter, epsilon, and as it was, I'll make it a bit bigger. Like as I said, it's this parameter means that 10% of the time we would send traffic to the random chatbot, and rest 90% we will send to the best performing so far. And also this, actually I forgot to mention it, these algorithms, they have one more parameter which is called exploration versus exploitation. So what does it mean? Exploration, it's the phase when we train the model, like to put it very simple, and exploitation is when we use the trained model for prediction. So pretty much like this. And like 20% I would say roughly it's okay. So now let's go for the simulation based on the data. So I would start maybe without cumulative and make the delay 100, 0.01, and 300 observations. That's roughly our like target group to whom we want to show the bot. So now if I start the simulation, it's a bit unfortunate, the screen side. Okay. Well, what happens actually? Maybe I will stop in the beginning, make it a bit slower, and start all over again. Okay, so I will stop maybe right here. We have two graphs here. So I go from top down, from left to right. So the first graph is actually this acceptable answer rate. So it's just the metric we're comparing, and this metric, how it evolves for all three bots. So let's say the blue bot shown us 0.7, almost 0.7 performance in this first round. The light blue 0.67, and the red one 0.61. So in the next iteration, which is this, we start from 0, yeah, in programming, the one we get some other metric based on the distribution so far. Here we will see, it's not visible yet, the real distribution of values over the time, and here we will see how much traffic actually went to which hand. So I will now start it. Yeah, and also the graph below, maybe that's also important. These two are the same, so it's how much traffic we send to one hand, how much, what are distributions. But here you might see the difference. So you see that here at the point of time 0, it sends traffic to all three bots, while multi-arm bandits sends it only to one at a time. And it's actually important because we will see later which advantage it has. So now I will let it run fully. And so here we would have the graph of the performance of the bots over the time. So as expected, the blue bot, it has higher peaks and also more like of a lower values because it's unstable, but also on average it's higher. And also what is important to say, you see how the traffic is allocated. So the traffic now is allocated to all three bots equally. And actually we designed 300 trial groups. That means like times 3 bots, we have 900 observations. And indeed, maybe if I make it smaller, it will be better. Yeah. Indeed, 900 clients were allocated to the bot, and equally 300 to each group. So now when we look in the, what meanwhile the multi-armed bandit did. In the beginning, explored a lot, and then when he figured out which bot performs the best, and this is the blue bot, it gives all the traffic, almost all the traffic to the blue bot, sometimes giving it to the red and light blue. So from distribution viewpoint, we see that it learned exactly the same. Distributions are the same, and like I didn't do it here, but if we conduct the proper testing, it will be able to detect the difference between groups. But the last graph maybe is the most interesting. We see that actually over the time, the bandit did allocation of more traffic to the highest performing bot. So I'll start it all over again so we see it from the beginning. You see in the beginning, it allocates traffic equally, but once he learned which one is the best, he starts to allocate more to those which is the best. And these can also, okay, I'll wait it to finish. Okay. So, and also this, if we try to see it cumulative, so it will do exact same job, but the values are now cumulative. So we are adding them up during the sessions. And you see again that for A/B testing, the all cumulative curves are equal. That means the traffic is allocated equally. And for A/B test, once he learned which algorithm performs better, it gives more traffic to this one. So this cumulative curve is actually ending up higher. And here you see the summed up values of the, like that's actually a reward. In our case, this acceptable answer rate, I guess, like summing up acceptable answer rate makes not much sense statistically, but the idea is that also by summing up, we see that the bandit, we are able to gain overall more, let's call it reward or some utility comparing to A/B test. I think that's pretty much it from my side. If you're interested, I really encourage you to try it yourself. So you can try simulation for different sample sizes and also different algorithms. By the way, we can try softmax with, yeah, I think tau 10% would be okay. And if I start all over again, actually with different algorithms, it's performing differently. So you see with actually softmax, it tries to still keep them balanced. So it's a little bit about the hyperparameter tuning. And yeah, I would say with A/B test, it's a little bit more work with figuring out why we get the results which we get. That's it, I think, from my side. I hope there will be, yeah, please.
What do you do with the result? Does it mean you then just take the configuration on for the weekend deployed bots and just go on with the best performing one until the next deployment? Or do you just leave it, to just rely on the distribution?
Yeah. What happens to actually all of them, all remain live. While in a classical A/B test, you finish the test and you, let's say you had 3 chatbots, you cut 2 of them and 1 is left. With this bandit approach, actually the test never ends, and you just, that's also an advantage I didn't mention, you can add new groups during the test, which is normally not possible with A/B test. Once you define these 3 groups, it just stays until the end. With this bandit, you made new feature, you add it up there as a new group, and you see how it performs over the time. If you see it's growing fast, well, then you make a decision. Like eventually you can turn off some of them. It's also totally fine. And the idea, like how it pop up in general, when I think it was 2-3 months ago, the question arose in our hub, which chatbot to keep. The first idea was the A/B test. And actually, I had this task to define the A/B test, how much sample we need, and so on. And when I started to discuss, I understood that every week we have a new deployment, and every team, they are fighting for their chatbot. They're trying to make it better and better. And now I think it's even unfair to cut them after 1 month, and then what? They go do some reporting, or I don't know. Like, no offense to reporting guys, but yes, please.
You said you have different chatbots. What does it actually mean? Do you really have 3 different development teams churning out a new version of their chatbot every month or every week?
That would be a long talk. Let's say we have, right now, I'm not sure how much I can tell about how the hub works because some things are still, let's say, under construction. But we have 2 teams, totally separate, and then 1 team who does 2 versions of chatbot. I don't know if some of you probably with chatbots you're dealing with, Rasa as a software, and there is Rasa and Rasa Calm, and Rasa Classic is based on the just some classification model in predefined intents, and Rasa Calm, in a nutshell, does the same, but the classification is done by LLM. And then you have two of them, and also what happens quite a lot, that one of them performs better in some FAQ questions, and another performs better in other one. So what I try to achieve with this solution is just to give a tool, to, especially to management, to make decisions which will not, shoot the dog, and let the team, if they are able to improve their product, to improve their product. So that's, yeah.
I didn't understand where you get this rating of acceptable answers from. So how do you, you said at the beginning something like sometimes it's judged afterwards. So how do you do that?
Well, this data actually, sorry, I'll show the data. This data I got, and so far, believe me or not, but these are done by human annotators. So some poor souls, they get list of questions, the answers the chatbot provided, and they just tick mark. Yeah. Like it's a bigger scale, like from 1 to 4, but essentially that's how it's going on. I would say it can be improved. I think yesterday we had a very nice talk with this LLM as a judge, but I would say it's some music of the future.
Because then that delays your action even more when you say, well, you need to have these people rate the answers. So
it depends. Yeah, like actually there are quite a lot of them, so they're relatively quick. But maybe it refers a little bit. What is the timestamp? What is this 300 to 299 observation is? It can be 1 day, it can be 1 hour, it can be 1 week. It depends like how fast are you able to collect the data. For example, for some metrics, I will show now. Here, yeah, these metrics, let's say rating and NPS, we collect them automatically after each dialogue. And then you have your data immediately. So it just depends. The more dialogue you have, the more data comes in, and you can automatically, based on this data, adjust this balancing of the load. With this acceptable answer rate, fabrication rate, which is for LLMs is quite a topic, or incomplete answer rate, yeah, there it's done by human, and you have to wait or allocate more human.
Yeah, but then if you do it like with multiple humans, then you also have a variation of how these people would rate it. So probably I would do different than you would.
Yeah.
So
well, they have number of people and allocate the question randomly, and rely on the fact that once it's random allocation, then it's comparable, and also people are the same like each day. But otherwise, yeah, there are a lot of fair questions, but
No, it's just like I was just asking, I was just judging what you do. It's more like I was trying to figure out what I can take from that. With this algorithm we use that, and this gave us great results. Something that I could take for playing with it.
Yeah, sure.
My question was,
yeah, you can use like the tool also because it's Streamlit. There is a GitHub repo, and you can just pull it in. It will work on your laptop. Like to tell a bit how this approach pop up. Once I was given a task to do A/B test and started to like figure out how it's done now and what's going on, and then I saw, okay, that's probably space for improvement, and that's how all this thing arose. And actually, I was like, I'm not so long in telecom, like in Deutsche Telekom, but I haven't heard about A/B tests being run here anywhere. So, yeah, please.
How do you do it in a technical way? I mean, like usually for canary releases or for A/B tests, there is a service mesh configuration. So how do you implement this bandit approach?
Yeah, well, this is not done by me, so I cannot really tell you how it works, but yeah, I guess there should be a way. Like in general, this idea, I think with those of you who dealt with bandits before, it's nothing so much new. You can find it probably in some talks a lot. But what I liked about it, it's very simple, and I presented it also inside our team, and everybody understood, and I thought, okay, probably that's...
It works live, so it means like it's
automatically adjusted. Yes, of course. Like the idea, yes. How, how to say, there is some bright ideas we have, and then when it comes to production, you have a lot of, how to call it, clusters which try to fix it here and there, and I will not be surprised that in the end the traffic will be allocated each day manually. Like, I will not be surprised, but yeah, please.
When I have used chatbot, I as a user can in the end say, oh, were you happy with the response or not? Is this feedback also somewhat going
Yeah, that's one of the metrics that's actually this rating or NPS. I would even say, like, what's the advantage? Like, these two we're collecting right now, this rating and NPS. Maybe it has some bias, because usually when person is happy, he will just type nothing, and only when he's unhappy, he will type something. But okay, then in this case, we optimize for less unhappiness based on conversation. Or what I think others also used, like for us it didn't work, you can also look at the metrics like length of conversation, because normally this is very common for e-commerce. They want you to be able to buy things with as few clicks as possible. So I would say some similar metric here can work out, that we want customer to get their answer as soon as possible, not typing in with chatbot for half an hour.